question 5, and this is an 11-mark question on metals. You can see in paper 2 they get longer and longer in terms of marks. So for per topic, the number of marks awarded is actually quite high. So let's get moving. Alright, so question 5 start off with something really easy, but they provide a context first. So it's all about metals. This question is all about metals and metal compound, just to give you a sensing. And the method of which we extract a metal depends on the reactivity of metals. So they want you to explain which method is used to extract sodium metal from sodium chloride. So first thing, if you can break down this question, they want you to discuss what is the method. So you need to name the method. And then you need to explain why, okay? So part 2 is why. So before we look into the answers, you should already have this at the back of your head. And what do I mean by this is the reactivity series of metals, as you can see on the right hand side, okay? So we start off with K, which is potassium, then sodium, calcium, magnesium, aluminium, and then in the bracket is our carbon, and followed by zinc, iron, lead, and then our hydrogen, copper, silver, and gold. Now, one thing to take note here is, although our carbon and hydrogen, they are non-metals, they are very, very important in this series. First, to help you identify how are the metals extracted. Okay, so the carbon is there to help you identify the methods of extractions. So, basically anything below carbon, will be extracted by reduction of coke. Coke is basically a type of carbon compound. But if it's above carbon, which is this group over here, then the only way to extract these metals is by electrolysis. As you can see, our sodium is the second on the list. That means it's really, really reactive. So the only way to get pure sodium out of this compound, in this case from sodium chloride, is using electrolysis. Okay, so the carbon is there to help you differentiate what is the method to extract the pure metals. So again, above carbon, we use electrolysis. Then what is I'm going to take a moment here to help you appreciate the H over here. The H over here, basically, it means that anything below H's, okay, below the H, which is hydrogen, these metals are considered unreactive metals. Okay, so we have our copper, silver, and gold. They are unreactive, and what this mean in terms of chemistry sense is they cannot react with acids. Okay, so we have copper, silver, and gold not being able to react with acid. So I'm going to take away all of this first, so it will not it will not distract us when it comes to the explanation of part 1. So the method is electrolysis, but you need to explain the why. Okay, so it's because sodium is higher than carbon in the reactivity series. So you do need to give a comparison of where sodium's position is in respect to carbon in order to get your second mark. Okay, or you could just simply say that sodium is more reactive than carbon. So regardless of which way you are writing out for your second point, you need to compare it to the carbon position in the reactivity series. That means you need to have this series in your brain before you can actually answer and get point to second mark of this question. Alright, then we look into part B. Part B here, we're looking at pure metals, arrangement of particles in pure metals. So say for example, you need something very visual. This can be a piece of iron. In fact, if you need to be clearer, you can just imagine this as a piece of paperclip, right? And what's happening here is paperclip is made out of full iron. And this is basically how it will look like if you have a very strong microscope, right? And we need to explain why the pure metals are soft. So visually, you need to be able to describe this structure that's given to you, right? So pure metals, they have layers of atoms and they are of the same size. Okay, so this is layer 1, layer 2, and layer 3. And all of the atoms within each of the layer is of the same size. So when they are of the same size, these layers can actually slide over easily. Therefore, pure metals are soft. Okay, take note, only pure metals are soft. However, if you maybe I just take a moment here to give you the opposite. So what is the opposite of pure metals? It is what we call alloys. Okay, alloys is a mixture of two or more types of metals. Sometimes there's also a non-metal involved in that, right? So we have like stainless steel being a very common example. And what's in our alloys here is because they are made up of atoms of different size, and because of that, it will distort the arrangement, the orderly arrangement. And so it is the atoms cannot slide over cannot slide over easily, and therefore alloy is considered stronger or harder in that sense. Okay, so this is the opposite of pure metal. However, there are some words that you need to take note of, which is over here. Right, if you mention of anything along the line that electrons are the ones sliding, which is a big no-no, then you will not get marks. That what is sliding is the layers of atoms, so take note of that in terms of wordings. Some students some students think that the reason why pure metals are soft is because of the weak intermolecular force, which again is wrong as well. What is happening, or what exactly is the force in metals, is actually strong electrostatic forces of attraction. Again, it's between the valence electron and the positive proton, but we're not going to talk about that today. So I just want to draw your attention to what are the common words that students are using in their answers, and try not to use them. Okay, so finally, we are looking at part C. Part C is a 2-mark question. It's a very easily done question. They want you to describe, in terms of electron, what happens when sodium reacts with oxygen. So you need to describe. So here we are trying to be clear that because sodium is a metal and oxygen is a non-metal, what is going to result in this two is ionic bonding. Okay, so ionic bonding have the metals losing electrons and the non-metal gaining electrons. Okay, so what's going to happen to the sodium? You can see that sodium has one valence electron. Okay, again, the word valence means outermost. There's only one. Whereas oxygen, it has 6. So it actually needs 2 more electrons to become stable. So how do we word this then? Is that this sodium metal or sodium atom will actually lose 1 valence electron, but the oxygen atom will be gaining 2 electrons each. So how are we going to give you these 2 marks here? Is that first you need to be clear that the metals are the one that's losing electrons, and the non-metals are the one gaining electrons. And how many exactly will actually give you this one? Will give you your second mark. Okay, so this is basically how you will word out your answers if you are asked about describing in terms of electrons between the metal and non-metal. Alright, so for question 5, this is the part 1. So what I'm going to do here is, because part 2 is a bit lengthy, I'm going to break this video into 2 parts. So follow along for part 2 of metals. There is another 5 marks over there. See you in the next one.